Today we move on to the geometric series, which is basically the sum of a geometric sequence, and we're going to develop a formula for the series pretty much the same way Gauss did. And again, Gauss was a little guy when he did this. Now, we remember what Gauss did when he was working with the arithmetic was he reversed the order of that arithmetic series and found out the sum was the same. He tried the same thing for the geometric, but it didn't work. So he had to come up with another trick. And his trick was this. All right? He took and multiplied every term in the series by the ratio. So he took and said, what if I take and multiply the ratio by this sum? Well, if I multiply the ratio by the sum, then he would distribute r to each one of these terms. So it turns out that when he distributed r through, this first term became the second term. This term, second term, became the third term. So on and so forth. Until he did the multiplication on the last term, and when he multiplied this last term by r, we remember we add the powers, so that was a1 or a sub 1 times r. And now he noticed, hey, I've got a lot of the same things stacked up underneath each other, kind of like he did with the arithmetic, but he had these extra two terms, so he couldn't use the same kind of formulation as he did earlier. So here's what he did. He said, well, look, if I take and subtract all this, then anything that's alike is going to subtract out. All right? And I have the sum of n terms minus r times the sum of n terms is equal to the first term 0, 0, 0, 0, 0, 0, but I have this last term in here that I'm subtracting out. And then he said, well, hey, I can isolate this by pulling out this sum, which leaves me with 1 minus r, and then I can factor out an a1 and have 1 minus r to the n here, and I end up with the sum equals the first term times 1 minus the ratio raised to the n power over 1 minus the ratio. And that's the formula we actually use. The sum of n terms in a geometric series is equal to the first term times 1 minus the ratio raised to the number of terms over 1 minus the ratio. So let's do a number of these problems. Sum of the first 12 geometric terms where I have my first term and my ratio of -3. And again, the sum equals the first term, 1 minus the ratio to the n power over 1 minus the ratio. So I take my first term, plug it in, there's a 4, 1 minus -3. How many terms do I have? 12 over 1 minus that ratio. And this is just a plug and chug problem. So it becomes calculator oriented, and I get a sum of -531,440. Again, we'll find the sum. Here's my first term, my last term, and my ratio. Well, again, if I just write this formula out, I have first term 1 minus my ratio to the n power over 1 minus my ratio. That's great that I have that first term. It's 48. 1 minus, I have a ratio of 1/2. That's good as well. But I don't have the number of terms. So I'm going to need to do that. I'll go back to my sequence equation, which says the nth term is equal to a1 multiplied by r to the n minus 1 and see if I can find it from here. I know my third term is 3, my first term is 48, and my ratio is a half to the n minus 1. Well, now I have everything but the number of terms, which is exactly what I need. So I'm going to go through. This is 1/16 is equal to a half to the n minus 1 power. I can get the same base. This is a half to the fourth is equal to a half to the n minus 1. Therefore, 4 equals n minus 1, and n equals 5. So now I can plug this in, and I have 48, 1 minus 1/2 raised to the 5th power over basically a half. And that's equal to the sum of the first 5 terms. And that gives me a total of 93. So here's our sigma notation again. Let's just verify this is a geometric series. Find the first term by plugging 1 in. I end up with 2 times negative 5 raised to the 0 power. We know anything to the 0 power is 1, so that's just 2. My second term is 2 times negative 5 raised to the first power, which is negative 10. My third term is 2 times negative 5 raised to the second power, which is 50. It appears we're multiplying by negative 5. So true, it is geometric. So in that geometric formula, I have first term, which is 2, 1 minus the ratio, which I know is negative 5. Number of terms is 12 over 1 minus that ratio. And we're going to get the sum of the first 12 terms. The answer to this is actually rather large. Negative 81,380,208. This problem is a little bit more involved. We have a geometric series where the second term is negative 36, the fifth term is 972, and we want to find the sum of the first 7 terms. Well, we've got an equation, S of 7 equals the first term times 1 minus the ratio raised to the n, and n in this case is 7, all over 1 minus the ratio. Problem is we don't have the first term, so let's start by getting that, and then maybe we can get the ratio and get this problem done. I have a sequence equation that says the nth term is equal to the first term times the ratio to the n minus 1 power. And I know I have the second term, so I'll call that a sub 2 is equal to the first term, which we don't know, times the ratio, which we also don't know, but I have the n value now of 2. This gives me the second term equals the first term times r. So I have the second term in this case being negative 36 equals the first term times the ratio. The problem is I have 2 unknowns. I need another equation so I can make a substitution and solve for one of those unknowns. Let's do that again with this fifth term. So I have the fifth term equals the first term times the ratio to the 5 minus 1 power, or the fifth term is equal to the first term times the ratio to the fourth. That fifth term in this case, being 972, is equal to the first term times the ratio to the fourth. I'll take and solve for the first term over here and get the first term is equal to negative 36 over the ratio. Substituting back over to here, I have 972 is equal to that first term, which we now know as negative 36 over r times r to the fourth. R to the fourth over r reduces to r cubed, so I have negative 36 times r cubed is equal to 972. My next step will be to divide negative 36 to the other side, and 972 divided by negative 36 is going to be equal to negative 27. That's going to equal r cubed, therefore r is equal to negative 3. If I know r is equal to negative 3, I can plug that back into this equation. I have negative 36 over negative 3 is equal to that first term. Alright, and that's going to be equal to a positive 12 is equal to the first term. Now I can plug back into my original equation because I have a value for the first term and I have a value for my ratio. So I go back over to here, say my first term is 12 times 1 minus that ratio of negative 3 raised to the 7th power all over 1 minus that ratio of negative 3. Cleaning that up, I'm going to pop that into a calculator. I have 12 times, this ends up being 2188 all over 4. Now we can finish up. So this is 3 times 2188, which gives us the sum of those first 7 terms is 6564. Like I said, a little more involved. So in this problem, we know our sum is 315. It's geometric because we have a ratio here. Therefore, I need my first term. 1 minus my ratio. There's 6 terms total, so I have the end value over a half. Multiplying the half to the other side, I have 315 over 2 is equal to the first term times 1 minus 1/2 to the 6th is 1/64. So that's 315 over 2 equals 63 over 64 times the first term. Therefore, 315 over 2 multiplied by 64 over 63 equals that first term, which gives me a total of 160 for my first term. Now if I have my first term and I know it's geometric, I can find my fourth term. 160 multiplied by my ratio of a half raised to the 4 minus 1 power. So this is 160. Half raised to the 3rd power is an 1/8. And therefore my fourth term is 20. And that's all we've got. Make sure you fill out that lesson summary and do your Connect Ed.